Okay guys, today we're looking at Unit 10, Lesson 2, transformations, domain and range, still looking at the root functions like in Lesson 1. So the first thing in the first video we're going to talk about are the transformations. Now we've discussed transformations several times in the first semester, so I'm just going to go through a real quick review of this, and we're going to look mainly at just the root functions. So first things first, all of the transformations come off of the parent function. So our parent function for the square root is f of x equals the square root of x, and it looks like this right here. And it's going up forever and ever and ever, just like that. So we have 4 different transformations that we're going to talk about. The first one, real quick, is a horizontal transformation. Horizontal left and right, so just like the x-axis. And so this transformation comes when there's something under the square root with x. So an example of that, real quick, would be f of x equals the square root of x plus 2. And whenever it's underneath the radical, or the square root, it's always the opposite. And so horizontal, remember this means left or right. Right. And so for a horizontal transformation, remember I just said it's the opposite. And so since this says plus 2, this means that we'll just go to the left 2 units. That's that transformation. And so looking up, here's my parent function, my transformation right here. I'm going to go to the left 2, so 1, 2, and then it makes the same sort of graph. I just shifted it over to the left 2. Alright, so anytime you have plus or minus under the square root, that's going to be horizontal, and remember that it is the opposite. So if it's minus f of x equals the square root of x, let's say minus 3, then this means to the right 3. Alright, we good? We got it? Alright, cool deal. So let's go on. Let's look at a vertical transformation. So vertical goes up and down like the y-axis. So this is up and down. And so this is like the x-axis, and so this is going to be like the y-axis. And the vertical transformation is straightforward, and instead of it being underneath the square root like this, it'll be on the outside. So an example of that real quick, f of x equals the square root of x, and there's nothing under it, nothing under the square root. Can y'all see that? Dang. It's going to have to be good enough for right now. So I have the square root of x, nothing's underneath it, and if I just stick a plus 1 on the outside of the square root, hang on, I want y'all to be able to see this. Okay, magic, we got it. If I stick it on the outside, square root of x plus 1, then since it's on the outside, this is a vertical transformation, and it does exactly what it says. It's not going to be the opposite like the horizontal. It says exactly what it means. So plus 1, the transformation is just up 1. Alright, so if I had f of x equals the square root of x minus 7, well, it's on the outside, so it just means down 7. And so what's that going to look like? Let's graph this one right here. I have my original parent function starts at the origin, and so this one right here, instead of starting at the origin, we would go down 7. So 1, 2, 3, 4, 5, 6, 7, and then whoop, just like that. Alright, so those are our horizontal and vertical transformations. So let's look at a vertical stretch or compression. And so what's this mean? A stretch is going to literally stretch it up like that, stretch it up, I don't know, it's kind of hard to see. And a vertical compression is going to squish it back down. So squish it back closer to the x-axis. And this transformation, you're going to find it out front of the square root. So say f of x equals 2 square roots of x. This is an example of a vertical stretch or compression. And so how do we know, is this a stretch or is it a compression? If the number that's out front, is greater than 1. So if it's greater than 1, then we have a stretch. Greater than 1 gives us a stretch. So in this case, I have 2, and so this is a vertical stretch. If the number that's in front of the square root is less than 1, so let's say I have a third, that's definitely less than 1, then we're going to have a compression. So less than 1 is a compression. And if it's negative, we're still just looking at the number. So f of x equals negative 7 square roots of x. As far as a vertical stretch or compression goes, the negative doesn't have an effect on it. We're still just looking at the number itself. And so the 7 is greater than 1, and so we're going to have, again, a stretch. All right? All right, so last one, real quick, let's talk about what does that negative actually mean. The negative, this is going to be a reflection over the x-axis. So anytime there's a negative out front, it's just going to reflect it over the x-axis. So we can look at this same exact example, negative, we'll just look at negative square root of x. How about that? Negative square root of x. Instead of it being in the first quadrant, like the parent function was, now I have this negative out front, so what that does, takes it and flips it over the x-axis. So instead of it being here, it's going to flip it over, and now it's here. And so here's our reflection. All right, and those are our 4 transformations. We got them? We good? All right, look out for the next video. Hope y'all are having a good day. Bye.